Okay, so let's have a look at these graphs, and we'll go through the steps that we did in the last lesson. So the first thing I want to find is the vertical and horizontal asymptotes. In order to find the vertical asymptotes, I need to have this function factored so that I can determine which values in the denominator are undefined. So I'll just factor the bottom quadratic, what's that, -4 plus 3. Okay, so once I have it factored, I can determine my vertical asymptotes because I know the denominator cannot equal 0. So either x minus 4 cannot equal 0 and 4, or x plus 3 cannot equal 0, and the other one's at -3. So I have two vertical asymptotes in this question. Okay, so I'm going to start my graph by drawing those onto my grid. So I've got one at 4, and then I've got one at -3. The second thing I want to determine is my horizontal asymptote. And I'm just going to go by those three shortcut rules. I am going to look at the degree. The degree in the denominator is greater than the degree in the numerator. So that means that my horizontal asymptote will be at 0. Okay, so we had three rules. If the degree in the bottom is bigger, it will be 0. If the degree in the top is bigger, it'll be oblique. And if the degree is the same, it will be the leading coefficient. So my horizontal asymptote is at 0. So I'll just draw that in. Then I'm going to determine my x and y intercepts. So my x-intercept y is 0. So when the value of y is 0, my x-intercept will be determined by the numerator because the denominator is going to get cross-multiplied by 0. So that will eliminate the denominator. So my x-intercept's at 0, 0. And my y-intercept, I'm going to let x equal 0. What's my equation? Minus x minus 12, so that's also 0. So I have a x and y-intercept at 0, 0. You'll notice that is on the x-axis, which is also a horizontal asymptote. Just keep in mind that it is possible to pass through an asymptote. So it is possible to have that right on the x-axis. Okay, the next thing, I'm just going to state the domain and range since I've already determined my vertical and horizontal asymptotes. So I could now state my domain and range. So my domain is any number but not at those asymptotes, so not at -3 and 4. And my range is any number but not at 0. Yep. And then we are going to do our interval table to finish off the graph. Okay, so now I'm going to do an interval table to finish off the sketch. So the intervals I want to check are the vertical asymptotes. So that's where the graph is going to change from going above the x-axis and below, and also that x-intercept. So the intervals I want to check are at -3, 0, and 4. So I want to check to the left of -3, in between -3 and 0, in between 0 and 4, and then to the right of 4. So we'll make our table down here. And this helps me finish off my sketch. So the intervals I want to check are from -infinity to -3, from -3 to 0, from 0 to 4, and then from 4 to +infinity. And then down the side, we'll put our numerator, which is 2x, and then our denominator in factored form, So it'll be x plus 3 and x minus 4. You don't really need to separate the numerator and denominator. It's up to you. In the guide they do, but you can just put them as that. And then we'll just pick some numbers. Okay, so I'm going to pick a number less than -3. I'll pick -4. So negative, negative, negative. So combined, that will give me a negative result. So it's below the x-axis there. And then between -3 and 0, I'll pick -2. Negative, so that's positive. Between 0 and 4, I'll pick 2. Positive, positive, negative. And then between 4 and positive infinity, I'll just pick 5. So that helps me finish my sketch. So to the left of -3, it's negative. So here it would be negative below the x-axis, approaching the horizontal and vertical asymptotes. Then it is positive. So it would approach the vertical asymptote there. Then it goes negative. So it would approach the vertical asymptote there. And then it is positive, approaching the vertical and horizontal asymptotes. So the graph does indeed pass through 0, 0. The horizontal asymptote just means that the graph will approach 0 when I go to positive infinity and negative infinity. So when I go really, really big to the right or really, really big to the left, that horizontal asymptote is where the graph will approach. It does not mean that it can't pass through it. So it does pass through it. And then you would want to now determine your intervals of increase and decrease, and also positive and negative intervals. So what number is this? 7. So I'll just do positive and negative intervals because I can read that right off the table. Right? It tells me where the graph is positive and negative in the table. So it's negative here and here. So in the intervals negative infinity to -3, and in the interval 0 to 4. And then it's positive here and here. So between -3 and 0, and to the right of 4. Okay, so that's pretty easy to read off the graph. And then increasing and decreasing is the final thing. And that I'm just going to look at the graph. So increasing is when it goes up from left to right, and decreasing when it goes down from left to right. Well, it's going down in the first part, it's going down in the second part, and it's going down in the third part. So there are no increasing intervals. So we just write none. And then it's going down. So these are 3 separate intervals because there's breaks in between. So I'll write them from negative infinity to -3, and then between -3 and 4, and then between 4 and positive infinity. Okay, so that just finishes it off. So we always do our intervals once we have finished the sketch and the table. All right, let's do one more. So this one, we want to factor the denominator so that we can determine the vertical asymptote. So again, it has 2. So vertical asymptotes. Remember that you have to have a variable. These are lines. So we have vertical asymptotes at x equals 4. So I'll draw that on. And x equals -4. My horizontal asymptote, I'll look at my rule. The degree in the bottom is bigger, so it's at 0. So again, it's going to approach 0 as I get really, really big and really, really small. Does not mean I can't pass through it or sit on it. It just means that it will approach it to infinity on both sides. Okay, C, x-intercept. There is none because there is no variable in the numerator. So if I let f of x equals 0 and multiply by the denominator, I will get 0 equals 2, which means there's none. The y-intercept, we'll let x equal 0. So we get y equals 2 over 0 minus 16. So that gives me a y-intercept of -1 over 8. So I do have a y-intercept, but no x-intercept. So my y-intercept's about here. From here, I can also state the domain and range because I have my asymptotes. So domain is any number, but not where the vertical asymptotes occur. So not at 4 and -4. And the range, we can have any number, but not at 0. Okay. Now we want to finish our sketch. So let's do our interval table. So the intervals I want to check, I don't have an x-intercept, but I have 2 vertical. So one at -4 here, and one at +4 there. Okay, I don't have any number on the x-axis, so that's not going to be part of my intervals. So we want to the left of -4, between -4 and 4, and then to the right of 4. And then I'm going to put the 2 in. It's not going to change my result, but it's a good habit if you have that numerator, whether it's positive. If it's negative, it's definitely going to change the result. Since it's positive, it's not, but it's kind of a good habit to get into to include it. So 2 is going to be positive regardless of the interval it's in. And I'll pick a number less than -4. So that's positive. And then I'm going to pick, I don't know, 0, negative, and then I'm going to pick 5, positive. So I can finish off my graph. It is positive to the left and right of the, so it's positive here, approaching both asymptotes, and it's positive here, approaching both asymptotes, and then it's completely negative here, passing through the y-intercept and approaching the asymptotes from both sides. Okay, so that's what the graph looks like. And then I can do my intervals. So my positive intervals are when x is less than -4 and when x is greater than 4. And then my negative interval is between -4 and 4. And then increasing interval and decreasing interval. So let's look at the graph. So it's increasing in this interval here. So it's increasing here from -infinity to -4. Then it's increasing from -4 and then to 0. Then it is decreasing, right? So this is a decreasing interval, and this is a decreasing interval. Okay? So increasing between, increasing between -infinity and -4, and then again between -4 and 0, and then decreasing from 0 to 4 and from 4 to infinity. Okay, so increasing and then it goes decreasing. All right, so those are a couple of different rational expressions. Again, going through all the steps in the same order as we did before.